Find the limit as x approaches 0. So in reference to the table of values here, we would like to get the limit as x approaches 0. Though we see an error here, this gives us that when x is 0, f of x is undefined. Okay, the question here is to get the limit. So the values here are from the left of 0, and this gives us from the right of 0. So let us identify the limit of the function as x approaches 0 from the left, and the limit of the function as x approaches 0 from the right. So observing the values as we move closer and closer to 0, f of x gets closer and closer to 0.5. And on this side, it is also approaching the same number, and that would be 0.5. So to answer the question, what is the limit of the function as x approaches 0, since the left-hand side limit is equal to the right-hand side limit of the function, then our answer is 0.5 for this table of values. Find the limit as x approaches -2. So this is x is equal to -2. This gives us the left-hand side limit of the function, and this would be the right-hand side limit. And since they are not equal, then the limit does not exist. So it would be D and E. Find the limit as x approaches 4 from the left. So let us trace our graph. So this is x is equal to 4. So this would be from the left of 4. And as we move closer and closer to 4, f of x or y approaches 1. So the answer here is 1. Okay, so if we write this one, the limit of the given function as x approaches 4 from the left is equal to 1. For this case, you'd like to identify the limit as x approaches 1 from the right. So this is 1, and this would be the behavior of the graph from the right of 1. And as we move closer and closer, our f of x get closer and closer to 0. So here, the limit of the function as x approaches 1 from the right is equal to 0. Find the limit of 7 as x approaches 5. So this is 7. Remember that the limit of a constant is itself. You just need to do straight substitution in this case. So square root of 9 plus 2 times 9 minus 1. So this would be 3 plus 18 minus 1. So we have 20. To answer this, let us use given. So by straight substitution, the limit of f of x would be 3 minus g of x is -1 over the limit of each of x would be 2 and then square. So I have 3 plus 1 over 4. So this is 4 over 4, which is equal to 1. Next we have x squared minus 36 over x minus 6 as x approaches 6. So let us identify first our f of 6. So doing straight substitution, we have 6 squared minus 36 over 6 minus 6. So this is 0 over 0. So this is in indeterminate form, and we can use factoring to get our limit. So the numerator can be factored as x plus 6 and then x minus 6 over then x minus 6. So x minus 6 can be cancelled. So what we have now would be the limit of x plus 6 as x approaches 6. So we have 6 plus 6, and the limit of this function is 12. If we try to substitute 0 to our function here, it would give us 0 over 0. So let us use the process of rationalization by multiplying this function to its conjugate. So its conjugate would be the square root of x plus 4 plus 2 over the square root of x plus 4 plus 2. So we have the limit as x approaches 0. So in the numerator, we can have the sum and difference of two binomials. So we have x plus 4 minus 4 over x times the square root of x plus 4 plus 2. So simplifying our numerator, that would be x over x times square root of x plus 4 plus 2. We can cancel x and we can have the limit as x approaches 0 of 1 over the square root of x plus 4 plus 2. And by substitution, we can have 1 over the square root of 0 plus 4 plus 2. So we have 1 over 2 plus 2, and that would be 1 over 4. Another case, if we try to substitute 3 to the given function, it would be 0 over 0. So let us use the process of multiplying this to its conjugate. So the conjugate would be the square root of x plus 1 plus 2. So the numerator would now be x plus 1 and then minus 4 over x minus 3, and just copy the other factor. So simplifying, our numerator would be x minus 3 over x minus 3 and square root of x plus 1 plus 2. So x minus 3 would be cancelled, giving us 1 over the square root of x plus 1 plus 2 as x approaches 3. So by straight substitution, we can have 1 over the square root of 3 plus 1 plus 2. So this is 1 over the square root of 4 plus 2, and that is, square root of 4 is 2 plus 2 is 4. So the answer to this question is 1 over 4. In this case, we are dealing with infinite limits. If we try to find f of negative 8, we have 1 over negative 8 plus 8. So we have 1 over 0. So if this would be the case that we're getting a number over 0, so we can use this strategy for infinite limits. So let us assign values from the right of negative 8. So that would be negative 7.999. So I have 1 over negative 7.999 plus 8. So the sign of the numerator is positive over, this would be positive. Positive divided by positive is positive. Therefore, this is positive infinity. Here we have the limit of x minus 3 over x plus 7 as x approaches negative 7. Let us first try to get f of negative 7. So negative 7 minus 3 over negative 7 plus 7. So this is negative 10 over 0. So this is another case of infinite limits. So let us first try to get the limit of the function, that's x minus 3 over x plus 7 as x approaches negative 7 from the right, and let us also get from the left. So assigning values from the right of negative 7, let us have negative 6.999 minus 3 over negative 6.999 plus 7. So the signs would be, the numerator is negative over, the denominator would be positive. To simplify, you negative divide positive, that's negative, so this is negative infinity. For the limit from the left-hand side of negative 7, so let us assign negative 7.001 minus 3, and we have negative 7.001 plus 7. Negative divide negative is positive, so this is positive infinity. Therefore, our answer to this question is D and E, or does not exist. This question involves the topic of limits at infinity. So we just need to compare the degree of the numerator and the denominator. So in this case, the highest degree is 2 and in the denominator is 5. The degree of the numerator is less than the degree of the denominator and this is at infinity. Then the answer here is 0. Okay, for this case, again, this is also limited infinity. Let us just compare the highest degree of the numerator and the denominator. So this would be 3 and the denominator would be 3. So since the degree of the numerator is equal to the degree of the denominator, so we just need to get the leading coefficient. So that would be 2 over 3. We need to identify the x values where the function is discontinuous and identify the discontinuity. So in reference to the given graph, we can see that we are discontinuous at x is equal to -2, 1, 4, and 6. So in this case, we can see that we're having a removable or whole discontinuity at x is equal to -2. The limit exists, but f of -2 is undefined. So this would be removable. At x is equal to 1, we can see a gap. Therefore, this would be jump. Same as at x is equal to 4, this is also jump. At x is equal to 6, this would be removable or whole discontinuity. So, as we can see again, the limit exists, but not equal to our f of 6. Let us identify if the function is continuous on the given interval. So for this case, -2 to 1. So this is an open interval. -2 is here. We can see a hole at -2 and at 1. But we're referring to the values between -2 and 1. So that would be greater than -2 but less than 1. And tracing the graph, we do not see any holes, gaps, or asymptotes. So this would be continuous. At 2 to 4, wherein 2 is included, so this is 2, including 2, and then tracing the graph up to 4, even though we have a hole at 4 here, but we're not including 4 in the given interval. And we do not see any discontinuity on this side, so we have continuous. 0 to 2, so this is 0, and then this would be 2. So if we try to trace the graph from 0 to 2, as we can see, we are including 1 wherein there is a discontinuity. Therefore, this would be discontinuous. For letter D, 4 to 5, including 4, so this would be 4 to 5. Though we are discontinuous at x is equal to 4, but on the given interval, we just need to identify if the function is continuous from 4 to 5. So this is continuous. Let us answer the following questions, and then this will be the given. So what is f of 3? So among these three, we're going to use 10x minus 1 to get f of 3. So we have 10 times 3 minus 1. So that would be 29. What is the limit of the function as x approaches 3 from the right? So this would be from the right of 3. So that would be 30. From the left of 3, we're going to use this function. X is less than 3. So I have 4 times 3 squared minus 2 times 3. So this would be 9 times 4 is 36 minus 6. So this is 30. For letter D, find the limit of the function as x approaches 3. So we just need to compare the left-hand side limit and the right-hand side limit of the function. And as we can see, 30 for the right-hand side and also 30 for the left-hand side. Therefore, the limit at 3 is also 30. And to answer if the function is continuous at x is equal to 3, again, we need to compare f of 3 and the limit of the function at x is equal to 3. If they are equal, then the function is continuous at 3. If not, then it is discontinuous. So looking at our answers, 29 is not equal to 3. So the answer here is no. Let us find the derivative of the given function. So this would be f prime of x is equal to, using our limit theorems, we can have 2x plus 2. So this is the derivative of this function. Find the slope of the tangent line of the given function at x is equal to 4. So getting f prime of x would be 3x squared plus 3. And you are asked to get specifically what is the slope of the tangent line at x is equal to 4. So we need to do f prime of 4. So that would be 3 times 4 squared plus 3. So this would be 3 by 16 plus 3. So I have 48 plus 3, so we have 51. So that is f prime of 4. Find the equation of the tangent line to the given function at x is equal to -1. So let us first get the slope at -1. So doing that, let us have the derivative of 3x cubed minus 2x plus 4. So that would be 9x squared minus 2. So the slope at -1 would be 9 times -1 squared minus 2. So this would be 9 minus 2. So f prime of -1 is equal to 7, or this would be our slope at -1. Now, let us first find what is the value of y when x is equal to -1, or let us identify f of -1. So this would be 3 times -1 cubed minus 2 times -1 plus 4. So I have 3 by -1 plus 2 plus 4. So this would be -3 plus 6. So I have 3. So this would be our f of -1. Or when x is -1, y is 3. So using our formula for the point slope form, we can have y minus y sub 1 is equal to m, then x minus x sub 1. So y minus y sub 1 would be 3, m would be 7, this is equal to m, and then x minus -1. So y minus 3 is equal to 7 times x plus 1. Simplifying, we have y minus 3 is equal to 7x plus 7. We just need to multiply 7 by x plus 1, and simplifying, we have 7x plus 7 plus 3. Adding 3 to both sides of our equation, and therefore to answer the question, the equation of the tangent line would be y is equal to 7x plus 10. Find the derivative. So remember, for this term, we can write this as x raised to -2. So to get the derivative by power rule, we have -2 x raised to -2 minus 1. And the derivative of 3x would be plus 3. And the derivative of 6 is 0. So let us simplify. This would be -2x raised to -3 plus 3. And therefore, g prime of x would be -2 over x cubed plus 3. Let us use product rule to get the derivative of the given function. So let us use this as u, and this is our v. So remember, we can use the formula u times the derivative of v plus v times the derivative of u. So doing this, h prime of x is equal to u. Let's copy 2x plus 5. Derivative of b, derivative of 3x squared minus 1 is 6x, plus b, 3x squared minus 1, and derivative of u, 2x plus 5 is 2. Okay, so let us multiply 6x by 2x plus 5. We have 12x squared plus 30x. And then multiplying 2 by 3x squared minus 1, we have 6x squared minus 2. And then simplifying, h prime of x would be 18x squared. So this would be 12x squared plus 6x squared, and then plus 30x minus 2. So this is now the derivative of the given function. Here, we're going to use quotient rule to get the derivative. So let us have, this would be u and v. So let us use the formula v and then derivative of u minus u derivative of v over v squared. So to get f prime of x would be b, let us copy our denominator. Derivative of our numerator is 3 minus, let us copy u, which is 3x minus 4. And then derivative of v, or the derivative of our denominator is 1 over the square of our denominator. So simplifying, we have 3x minus 15, multiplying 3 by x minus 5, and multiplying 1 by 3x minus 4 would be 3x minus 4 times negative would be negative 3x plus 4 over the square of our denominator. So this would be cancelled, 3x, and then negative 15 plus 4 is negative 11 all over the square of our denominator. So this is our derivative. Let us use chain rule to answer this question. So again, it is the derivative of the outside function leaving the inside function times the derivative of the inside function. So let us first copy our inside function, and by power rule, let us get the derivative of the outside function. We have 4, and then the exponent would be 4 minus 1. Multiplying to the derivative of the inside function. The derivative of the inside function is 4x, 2 times 2, and then x plus 3. So I have 4x plus 3. And then simplifying, let's multiply 4 by 4x plus 3. So the derivative would be 16x plus 18, and then let's copy the inside function raised to 3. Here we're going to use the combination of product rule and chain rule. So again, the formula for the product rule would be u derivative of v plus v derivative of u. So in this case, let us have u is equal to 4x and v is equal to x plus 2 raised to 5. So the derivative of u is equal to 4, and the derivative of v by chain rule is 5x plus 2 raised to 4. U would be 4x, and then derivative of v is 5 times x plus 2 raised to 4, plus v, that would be x plus 2 raised to 5, times the derivative of u, which is 4. So simplifying, we can multiply 4x by 5. So I have 20x, and then x plus 2 raised to 4, plus, this would be 4 times x plus 2 raised to 5. So this is now the derivative of the given function.